Alright, so 5 test-inspired warm-ups. So press pause, give those a try, and then we'll come back and go over them. There's a couple of hints if you want to pause there, see if that makes sense, and then try to keep going for both of those. And then we'll come back in a minute and go over them. Alright, so on number 1, that's the second fundamental theorem of calculus. The derivative of the integral will get you back to where you started, with the, not the exception, but with the caution that we have to chain rule. So we'll just plug the top limit in. So x cubed squared over 1 plus x cubed times 3x squared. And you can leave it like that. Like, that's a safe stop. Multiple choice test. Let's see, this would be x to the 6th. Power to a power we multiply. And 2 more would be x to the 8th. So it might look like that on a test question. You might do some more algebra simplifying. But free response, you'd be good to stop there. That would be fine. And I think most of you would not have trouble getting from one of those to the other. Number 2, or number 3 for now. Number 2, average value 1 over the width times the area, or the area divided by the width. And the area we get by taking the antiderivative. So 1/2 integral from, I can integrate that. X squared, let's see, increase the power by 1, divide by the new power. You increase -2 by 1, you don't get -3, right? You get -1. So 1/2 x squared plus 1 over x from 2 to 4. Again, not a safe stop because there's still calculus. That's calculus notation we need to do. So 1/2 16 plus 1/4 minus 4 plus 1/2, and that would be the average value. Like, safe stop. Like, this is what some of you were arguing about. Like, I bet you got there, and then now it's like, well, what's my calculator say? Did y'all come to an agreement on what this answer was?
No.
Still no. Okay. So let's see. 16 minus 4 is 12. 1/4 minus 1/2 is minus 1/4. 12 minus 1/4 would be 48/4 minus 1/4 would be 47/4. I think I saw this on somebody's paper.
I got 49/4.
49/4 if you maybe didn't distribute the minus to the 1/2. You ended up with a plus 1/4 there, maybe. I don't know. But that's the value of a safe stop, right? Like, don't mess this up. All right, the second part. So that's the average value. The second part says that 47/8 equals 2x minus 1 over x squared, somewhere on 2 to 4. Well, that would definitely be a calculator type problem. Because I can't solve that without a calculator. So with a calculator, you could get an answer. You won't have a calculator tomorrow or Thursday, so that means the algebra will be easier. You'll be able to solve it. But do check and make sure you get an answer, because it's possible you get more than one answer. Make sure your answer is on the given interval. All right, number 3. Let's do number 3 together, and then I'll let you try 4 and 5. Integral from negative 2 to 4 of absolute value of x minus 3. We don't have a special way to do absolute value. We just need to know that something's going on at x equals 3. You know what? Let's back up one step further. What does integral mean? What's one of the things it means? Antiderivative and area. Those are the two things it means. We're now, our brain is now thinking antiderivative because that's what we've been doing all of today's. Increase the power by 1 or use substitution. But let's think about area here. I want the area from negative 2 to 4 under this graph. Well, if I could sketch that graph, then I could maybe just use geometry rather than an antiderivative. Because there is no antiderivative for absolute value. There's no trick. I mean, the trick is draw the picture and figure it out. So something's going on at 3. In fact, let's think back parent functions here. There's the absolute value function. What does minus 3 in parentheses with x do to it? Moves it to the right 3. And the slope is 1 on each side. So I got to get back to, let's see, 1, 2, 3. So if I back up to negative 2, that width is 5, which means that height is 5. So now I'm just going to add the area of the two triangles. 25 over 2 plus 1/2 would be, well, you could leave it like that for 1 would be your answer. But 13. So don't forget that integral can mean area, but it can also mean antiderivative. And the first thing we learned was area, right? Remember doing all these little pictures and half circles and triangles and rectangles, and that's what we did first. Then we switched to antiderivative, and so your brain is used to trying to do the increase the power by 1 or derivative of sine is cosine, all those rules. But it's still both of these things. And so sometimes the area way is the easier way. And we get stuck because you start thinking, oh, how do I antiderivative an absolute value? And you forget that, wait a minute, I know what that picture looks like. Geometry is a lot easier than algebra, or than calculus sometimes. All right, try those last two. That's more recent, traditional use substitution type stuff. One with limits, one without. So give those a try. 6 or 7 minutes worth of trying, and then we'll go over them. If you're stuck and just waiting for me to go on, there's a couple of hints for what U is. But those are huge hints. It's just the first step of the problem, but that's the main part of getting the problem started, is picking U correctly. So, excuse me, even if you can finish it, given these two, what we should use for U, that's like more than half the problem is knowing what to pick for U. So if you can finish it from there, that's good, but you've got to be able to get U on your own. So I'll pause again, and maybe you can pause again, I should say, and see if you can take it from there. Okay, so let's go over these. Look like everybody did well on picking U and figuring out du and seeing how that works. On number 4, well, it's 3 minus sine x. So the derivative of sine is cosine. but the derivative of negative sign is negative cosine.
Yeah, like this.
Does that make sense?
Oh, I thought, yeah, I'm sorry, I missed that discussion.
So I need a negative one. Actually, I'm going to move the 2 out front and be done with it too. And I need a negative to make this work. So negative 2 integral u to the negative 2 du. But I need to change my limits to u limits. So u of pi over 2, 3 minus sine pi over 2. Sine pi over 2 is 1. U of 0, so I'll plug in 0 for x. Sine of 0 is 0, so 3. Here we are again where we're faced with not a dilemma, but a decision. You can leave it from 3 to 2. Feels backwards, but it's fine. It's still going to work out. Or you can switch it and change the negative. I'm in the habit of switching it because I feel like it looks better, but if you want to leave it, you can leave it. You'll still be okay. So I'm switching it. You don't have to. Some of you just keep it because it doesn't matter. You do the top limit minus the bottom limit. Switched or non-switched, it's always the top one minus the bottom one. And that's what switches the minus sign. Because I'm going to do top minus bottom. If I do it this way, I need to switch the sign. All right, u to the negative 2. So increase the power by 1, divide by the new power. There's still a 2 out there. So I'm going to make that negative 2. I'm going to just rewrite that as 1 over u. From 2 to 3. So negative 2, 1/3 minus 1/2. Save, stop, done. Now, if you wanted to keep going, 1/3 minus 1/2 is 2/6 is 1/6. 2/6 is 1/3. So I think it'd be 1/3.
No, I mean, we're plugging in sine.
Yes.
That's right, Ben. If you did the like 3 to the negative 1 power, would that still be the 6?
Yeah, that'd be fine too.
Okay.
Yep. The question was, could you leave it as 3 to the negative 1 minus 2 to the negative 1? Yeah. And again, if you didn't switch those limits, and you'd end up with 2 times 2 to the negative 1 minus 3 to the negative 1.
I divided by a negative 1 for those two.
And that's the same, where you could factor out a negative 1. And I mean,
Okay.
lots of algebra that would give you the same answer. Makes grading fun when there's 14 different right answers. Number 5. U will be the inside stuff. Du would be negative 12x dx. So I need a negative 6 on the inside and a negative 1/6 on the outside. So u to the 1/2 du. Not showing everything, but the bell's about to ring. Increase the power by 1. Divide by the new power. Keep the negative 1/6. And in the interest of time and not wanting to mess up my algebra, leave the safe stop alone. Plus c, plus c, plus c, because it was not a definite integral. So plus c. Obviously you could clean that up a little bit out front, but meh. Alright, test in 2 parts. Part 1 tomorrow, part 2 the next day. You've got the sheet that explains each part. Put it up one more time for our online friends at home.
Mr. Wolf, how do you find 2 part B? How do you find